All right, here we are on number 13. This one's kind of nice because all the statements are given, so you're just having to come up with reasons. So notice that this one has a lot of given information. When you have a lot of given information, a lot of times the proof will divide it up into different steps. So you notice you find some of it right here. And it's always a good thing to start with is going and figuring out where the given is so you have something that you can write. You can go ahead and fill in given. So that's 1 is congruent to 4, and 3 and 4 are supplementary, also given. So I can put given in both of those places. Now I need to go back to step 2 and see how I'm supposed to know this. So if I know that angle 1 is congruent to angle 4, that means their measures are equal, because that's what congruent means. Anytime you're thinking, well, because that's what that means, it's probably definition of something. Okay, so since that's what congruent means, I can say their measurements are equal when I know they're congruent. So I say definition of congruent, or of congruent angles. You can say of congruent angles, or you can just use the little congruent symbol, but it's definition of congruent. You got to have that part. Definition of congruent. Now down here, we have another thing that comes from the step above it and is basically explaining what that means. This is a math term, the word supplementary. Pretty much anytime you have a math vocab word, pretty soon, either on that step or the next step, you're going to have definition of that word as your reason. So this says that 3 and 4 are supplementary, and supplementary means they add up to 180, so that's showing that's what it means. It means that 3 plus 4 equals 180, and because that's what supplementary means, we say that's definition of supplementary. Okay, so now we look at step 5, and you really have to notice if steps look a lot like one above them. So step 5 looks a lot like step 4. The only difference is in place of the angle 4, it says angle 1. When you see one thing in place of another thing, that's substituting. We're substituting something, okay? So since we plugged in something else in place of angle 4, and it's angle 1, that comes from the fact that they're equal. So that's substitution. Because we know that 1 is equal to 4, we can put 1 in place of 4. So that's substitution. Okay? Next. And this one seems a little bit random. It's like, well, where did that come from? So let's look. Looking up here, we look at the picture, because nothing else over here has been talking about 2 and 3. Angle 2 hasn't even been mentioned yet. So I'm going to go to the picture and figure out where 2 and 3 are. 2 and 3 are vertical angles. Vertical angles are always congruent. Okay, so the vertical angle theorem is what tells me that. Vertical angles are always congruent. You could just even say, you can say vertical angle theorem here, or you can say what the vertical angle theorem says, which is that vertical angles are congruent. Really, the theorem says they're congruent. This says they have equal measures. That could have been another step in here. We could have said 2 is congruent to 3 first and then changed it to measures are equal, but they went ahead and just went all the way with it. Vertical angles are congruent, or you could say vertical angles have equal measure. Okay, and now we have angle 2 plus angle 1 is 180. It's important to notice on step 7 how much this looks like steps 4 and 5. And we're just making another substitution. This time instead of angle 3, it says angle 2. So I am substituting angle 2 in place of angle 3 because angles 2 and 3 are the same. So I can put one in place of the other. And finally, since we know that 2 plus 1 is 180, that makes the lines parallel. We have to have a reason for that. So we go back up to the picture and look at why that would make the lines parallel. 2 and 1 are a special angle pair. They are same side interior angles. And when same side interior angles add up to 180, when they're supplementary, that means the lines must be parallel. So we're going to say this is because of same side interior angle converse. Because remember, anytime we use these angles to say that things are parallel, that's using a converse, that's going backwards. The same side interior angle theorem,
Steele, you're needed in the
excuse me for a sec.
Shelton Steele, You needed in the counseling office at this time, please.
The same side interior angle theorem, the original one says if we know the sides are parallel, or that we know the lines are parallel, then same side interior angles are congruent. This one's going the opposite way. We start out by knowing the same side interior angles are congruent, and it tells us that the lines are parallel. I think I may have said lines are congruent, I'm sorry. Lines are parallel. So whenever we end with knowing the lines are parallel, that's the converse. So we do need that word in there. So don't forget the word converse.